This is the introduction, and really in this first part of this video, what we're doing is we're talking a little bit about what people thought about matter early on. The introduction slide's actually this one, and it's not really about what people thought, but it's kind of some of the technology and sort of its current state. This is actually known as a carbon fiber nanotube. That's what CFNT stands for, carbon fiber nanotube. And MW just stands for multi-walled. And actually, when I was working at NASA for a short period of time, like 14, 15 years ago now, and I was asked to come and consult on something, and it was a project that was being worked on at the time. This is actually what we were using. This is not one of our micrographs, but it's the type of material that we're using to make electrodes, and these electrodes were presumably at the time everything had to be associated with the push to go to Mars, and so it was basically a sensor for detecting neurotransmitters, dopamine in particular, in astronauts. But the reality was we just said that because everything had to be tied to the mission to Mars. It was kind of a stupid, anyways, it's kind of a neat idea, but the way it was carried out wasn't very great. Anyways, so carbon atoms are about 0.07 nanometers. Now you'll notice this scale that's down here at the bottom left, that's 5 nanometers for that bar. That means that itself is about 5 nanometers. So each one of these bars is about 0.34 nanometers across, right? So 0.34 nanometers. So when you're looking at this image, just like a diffraction, what's the best way to explain it? It's like an interference pattern where electrons are beamed through the material. And we'll learn about the wave properties of electrons later, but it interacts at a scale of about 0.34 nanometers. And so what you're seeing in these rows are actually individual rows of carbon atoms. And they're 0.07 nanometers in radius, so they're about 0.14 nanometers in diameter. That's 10 to the minus 9, right? Nanometers in diameter. So actually like a segment here to here, that's got a couple of carbon atoms in it. So we're not actually seeing the atoms themselves, but it's giving us an idea of the structure of the atoms. Anyways, yeah, that's what we could do. We've been able to do this kind of stuff for quite some time. And so, for us, we see pictures of atoms all the time. If you're sort of involved anywhere in the sciences, you see scanning, tunneling micrographs or atomic force micrographs of proteins, and you see bumps, and so they say those are the atoms. And this gets to be a little bit sort of on the edge of truth and lies. What you're really seeing is a contour of the electron clouds for the atoms, and it's a little weird anyways. But we've been able to do this kind of stuff, especially recently in the last 20 years, to actually see the spacings of atoms and how they're arranged. But what we're going to do is go way back, okay? And I always like using this slide. This slide, I don't know if you recognize this band, right? But Democritus believed in atoms. He believed that there was some smallest unit to matter, and it can't get smaller than that. And Plato and Aristotle thought it was Earth, Wind, and Fire. So this is actually a picture from Earth, Wind, and Fire, right? I don't know if you've heard their music, but if you listen to it, you'll be like, oh yeah, these guys were cool. Yeah, that's what I kind of grew up being corrupted by. Earth, Wind, and Fire. Great music, had instrumental, all kinds of stuff, great vocal stuff. Anyways, long story short, back in those days, whoever could make the most asserted, I won't even say entirely logical, but most asserted, well accepted argument was accepted to be right. And so we went for a long time, thousands of years. Well, not really thousands, but pretty close to thousands of years, thinking that earth, wind, and fire, that there was some like element. That's what we get the word from, the elements, right? That like earth, wind, and fire, and water was the other one. But that didn't sound good as a band title. But was somehow part of the nature of matter, right? So fast forward, there's a guy named Robert Brown, and what Robert Brown did in the like early 1800s, and this is around the same time frame that we started to rethink, like at least sort of European modern science started rethinking the way matter was composed.